Somewhere beneath Iran's mountain ranges, there are military facilities that are not meant to be seen from the surface. They are described as underground missile cities, tunnel networks carved deep into rock, with roads, storage chambers, command areas, power systems, ventilation, and multiple concealed entrances spread across mountain terrain. The idea is simple, but extremely difficult to build. If weapons, aircraft, drones, fuel, and command systems are visible from the sky, they can be targeted from the sky. So Iran spent decades moving some of its most sensitive military infrastructure underground. This is not just a story about missiles. It is a story about geography, engineering, sanctions, and survival strategy. It is about how a country with limited access to foreign military technology used mountains, tunnels, and redundancy to create one of the most secretive underground military networks in the world. So how were Iran's underground missile cities built, and why did Iran decide to bury so much of its military power inside mountains? To understand the project, you have to go back to the Iran-Iraq War of the 1980s. During that conflict, Iranian cities and military sites were repeatedly attacked from the air. The lesson Iran took from the war was harsh. Anything exposed on the surface can be found, and anything that can be found can be hit. After the war, Iran began developing what it calls passive defense. This means protecting important systems not only by shooting down incoming attacks, but by hiding, hardening, dispersing, and burying critical infrastructure. Iran's geography made that possible. The country has major mountain ranges, including the Zagros in the west and the Alborz in the north. For engineers, those mountains are difficult terrain. For military planners, they are natural fortresses. Hundreds of meters of rock above a facility can provide protection that ordinary buildings cannot. Instead of placing missile depots, command posts, and launch systems in open areas, Iran began placing them inside mountains. Over time, this became more than a few bunkers. It became a distributed underground network, built province by province, tunnel by tunnel. A missile city is not just one tunnel. Based on public footage, satellite analysis, and military reporting, these sites appear to be large underground complexes with connected passageways, storage chambers, service areas, and concealed access points. The main tunnels are built wide enough for heavy military vehicles to move through. Some are reported to hold road-mobile missile launchers, large trucks that can carry, raise, and fire ballistic missiles. The advantage of that system is mobility. A launcher can be stored underground, moved through the tunnel network, and brought to a firing area or exit point when needed. Afterward, it can be moved again, making it harder to track. Iran has also shown footage of an automated rail-based launch system. In that setup, missiles appear to be moved through an underground magazine toward a vertical launch position. When one missile leaves the position, the rail system can move another into place. The important point is not the weapon itself. The important point is the infrastructure. These tunnel systems are designed to support storage, movement, protection, launch preparation, and command coordination inside a mountain. That requires far more than digging a hole. It requires power generation. It requires ventilation. It requires communications. It requires fuel handling. It requires internal roads or rails. It requires protected entrances and exits. And it requires enough separation that one strike cannot easily disable the whole site. This is why the entrances matter so much. In any underground facility, the entrance is usually the weakest point. Iran's reported solution is to use multiple exits, often spread across wide areas of mountain terrain. Some entrances are camouflaged or blended into the landscape. If one access point is damaged, other entrances may still be usable. Inside, connecting tunnels allow movement between different parts of the complex. That is the basic logic of the missile city: depth, concealment, movement, and redundancy. The same underground strategy does not stop with missiles. Iran has also displayed underground facilities connected to aircraft, drones, and naval forces. One of the most discussed examples is an underground airbase reportedly built into mountains near the Strait of Hormuz. Public footage has shown aircraft stored and serviced inside protected underground areas. For Iran, This matters because much of its air force is old and difficult to replace under sanctions. Protecting aircraft underground makes them harder to destroy before they can be used. The naval side follows a similar idea. Along the Persian Gulf and Gulf of Oman, Iran has developed bases for small, fast boats and missile boats. These forces are part of a strategy based on speed, numbers, and surprise. Underground or concealed coastal facilities allow boats to be hidden, serviced, and launched with less exposure from the air. Drones also fit into this network. Iran's drone program has become one of the country's most visible military tools, and underground storage helps protect those systems before launch. Together, these facilities create something larger than a missile program. They create a parallel military infrastructure, one Iran visible on the surface, and another hidden beneath rock. One of the most interesting parts of this story is how much of the construction happened while Iran was under heavy international sanctions. Sanctions limited Iran's access to advanced equipment, foreign contractors, and global financial systems. But tunnel construction was not completely new to the country. Iran has long experience with mining, mountain roads, water systems, railways, and civil tunneling. That civilian engineering base gave Iranian companies and engineers a foundation they could adapt for military projects. The country also learned from outside partners. Reports have long connected Iran's missile and underground construction development to North Korean expertise, especially in tunnel and silo design. China has also played a role in Iran's wider infrastructure and supply chains, although the military details remain difficult to verify from public sources. The construction itself likely combines several methods. In hard rock, engineers can use drill and blast techniques. For longer and more uniform tunnel sections, tunnel boring equipment may be used. Once excavated, the tunnels must be reinforced, ventilated, powered, connected, and hidden. The difficult part is not only digging, it is scale. A single tunnel can be found. A single bunker can be mapped. But a distributed network across multiple provinces creates a much harder problem. Even if some locations are identified, no attacker can be completely sure they have found every tunnel, every storage site, every command room, or every concealed exit. That uncertainty is part of the design. The reason underground systems are so valuable is that modern warfare depends heavily on seeing the target. Satellites, drones, aircraft, and intelligence networks are extremely good at finding surface activity. But mountain tunnels change the problem. A bomb can hit an entrance. A strike can damage roads, buildings, air defenses, or exposed launchers. But deeply buried infrastructure is much harder to confirm, reach, and destroy. Public reports from recent conflicts suggest that surface facilities and shallow sites can suffer serious damage, while deeper mountain complexes are more likely to survive or remain only temporarily disrupted. That is exactly what passive defense is designed to do. It does not make a country invincible. It makes a complete first strike much more difficult. If enough systems remain hidden and functional after an attack, the country can still respond. For Iran, that survivability is the whole point. Its leaders know they cannot match the United States or Israel aircraft for aircraft, or technology for technology. So the strategy is different. Instead of trying to dominate the sky, Iran tries to make its most important assets harder to eliminate from the sky. When you look at these missile cities as engineering projects, several principles stand out. First is depth. The deeper the facility, the more rock protects it. Second is distribution. Instead of relying on one giant base, the network is spread across many locations. Third is redundancy. Multiple entrances, backup systems, and connected tunnels mean one damaged point does not automatically destroy the entire facility. Fourth is concealment. The less visible the entrance, the road, the power system, or the movement pattern, the harder the site is to target. Fifth is independence. Underground facilities need their own power, air, communications, and logistics because they may have to operate even if the surface around them is damaged. These are the same ideas used in many hardened facilities around the world. Iran's version is shaped by its own geography, its sanctions, and its strategic fears. Iran's underground missile cities are controversial, secretive, and difficult to verify in full. But as an engineering story, they reveal something important about modern defense. In an age of satellites, drones, precision bombs, and long-range missiles, hiding underground has become one of the oldest ideas made new again. Mountains become shields. Tunnels become roads. Entrances become weak points to disguise and multiply. Power, air, fuel, communications, and storage all have to move below the surface. The result is a military network that is not built to be beautiful or visible. It is built to survive, and that is why Iran's underground missile cities matter. They show how a country under pressure can turn geography into defense, civil engineering into military infrastructure, and mountains into one of the hardest targets on Earth.